Let's move on to lesson 2, parallelograms. Now, I want to go ahead and refresh your memory about a few things. Last class period, we talked a lot about the different angles on the interiors and exteriors of polygons. And for the rest of the unit, we're going to be focusing specifically on quadrilaterals. Now, which means that all of our shapes are going to have 4 sides. Now, any generic shape with 4 sides is considered a quadrilateral. But there are special types of quadrilaterals, okay? Now, the first type we're going to be talking about today is a parallelogram. And we'll talk more about what parallelograms look like. Actually, there's one right there on the right, and I can't draw them very well freehand. Okay, there's a parallelogram, but what you've also got to realize is that there are special cases of parallelograms. There are 2 special types that we'll be covering later in the unit. Now, those are the rectangle and the, I know you're thinking square, but it's actually a rhombus. So, we'll talk about what all the different special properties of those are when we get there. And there's actually a special case of both a rectangle and a rhombus, and that is the square. Now, there's also another special type of quadrilateral that is not a parallelogram, and that is a trapezoid. So let me draw a trapezoid here. Those 2 are parallel. And then there's a special kind of trapezoid called an isosceles trapezoid. And that's going to be your traditional trapezoid that you think of like this, where these 2 are congruent. And we'll talk more about those all when we get there. Oh, and I forgot there's a third kind a third one that's also a quadrilateral, but not one of the other 2, and that is a kite. So we're going to be talking about all these different shapes over the next several days, and they're all going to have their own sets of properties and special conditions, and your job is going to be to keep track of what properties go with which quadrilateral so you can start using those. And yes, we will be using different pieces of these throughout the entire year. But I'll give you a nifty little tool as we get farther into this to help sort those out in your head. So let's go ahead and move on to our our parallelogram properties. We're going to start off with the definition. Sides and angles of parallelograms. A quadrilateral with both pairs of opposite sides congruent is a parallelogram. Now, when I say I used the wrong word there. I apologize. That should be parallel. Okay, so here JM is parallel to NK and JK is parallel to MN. It's called a parallelogram because it's got 2 sets of parallel sides. So, property 1. If a quadrilateral is a parallelogram, then opposite sides are also congruent. Okay, so in this one above, JK is going to be congruent to MN. And JM is going to be congruent to NK. Okay, also on a parallelogram, the opposite angles are also congruent. So up here, I know that angle J is congruent to angle N. And I also know that angle M is congruent to angle K. All right, if a quadrilateral is a parallelogram, then its consecutive angles, now when I say consecutive angles, I'm talking about like these 2. J and M are consecutive. J and K are consecutive. Those are supplementary. So angle J is supplementary to angle, J to angle K. M is supplementary to N. N is supplementary to K. And K is also supplementary to that. I got that all jacked up. It's not important to get every single one. Just realize every pair of consecutive angles is congruent. I could go back and fix that, but we just need to move on. Okay, if a parallelogram has one right angle, then it has 4 right angles. So if one angle is right, then the rest are right. So if angle J is 90 degrees, then the rest are also 90 degrees. And the reason for that, I know this isn't 90, but if J was 90 degrees, again, big if, we know that opposite angles are congruent, so that would also have to be 90. And we know that consecutive angles have to add to be 180. So 90 plus 90 would equal 180, and then therefore this one's also 180. That's where that comes from. So if you have one right angle, then you have all right angles. All right, let's see what we can do with number 1. It tells me ABCD is a parallelogram. Find the value for each variable. Well, I've got my A right here, and I know that opposite sides are congruent, so I know that 2A is congruent to 34. So 2A equals 34. Divide both sides by 2, and I'm going to get A equals 17. I also know that opposite angles are congruent, so I know that AB is equal to 112 degrees. And that's not one that I have memorized. 112 divided by 8 is 14. All right, number 2. Find the value of each variable. It tells me it's a parallelogram. Now, in particular, since it's a parallelogram, I know that these two angles are congruent. However, that's not going to help me very much at this moment. What I do know, though, is that these two angles together are 115 degrees. So what that means is that 115 plus 5x, if I add up my two consecutive angles, those are going to equal 180. So now we're just going to go ahead and start our solving steps. I need to get isolate x, so I'm going to subtract 115 on both sides. That's going to give me 5x is equal to 180 minus 115 is 65. Now we're going to divide both sides by 5, and that leaves me with x is equal to 13. Okay, now, if x is equal to 13, well, actually, I'll take it back. Let's just do this other side the exact same way. 115 plus 2y is equal to 180. Now I'm taking advantage of the fact that 115 and 2y, those have got to equal 180. So I'm going to subtract the 115 off. That gives me y is equal to 65. Exact same calculation I did on the other side. Divide both sides by 2, and now I'm going to get that y is equal to 32.5. Okay. Now, not only do we have special properties about sides and angles, the diagonals also have special properties, okay? The first one is that the diagonals bisect each other. So what that means is AP equals to PC and DP equals PB, okay? Now, the other thing is that whenever a quadrilateral is a parallelogram, each diagonal separates it into two congruent triangles. Now, to see that one, I'm going to highlight down one diagonal here. We've got this triangle and this triangle. So here, ADC is my blue triangle, is congruent to CAB, which is my orange triangle. Okay, and then also the same thing would happen if I did my other diagonal. So if I went down this diagonal here, this triangle is congruent to this triangle. So let's see if we can use those properties to solve these problems. I know that it's a parallelogram, so my diagonals bisect each other, which tells me that AE is congruent to EC. So 4y is equal to 18. We'll divide both sides by 4. 18 divided by 4 comes out to 4.5. Now, I also know that DE is congruent to EB, so I know that 6x is equal to 24. Divide both sides by 6, and I get x equals 4. On number 4, I've got 3 different variables that I need to solve for. So let's look at this. I've got 5x here. Now, I know I'm on parallelograms. Opposite sides are congruent, so look over the other side, and there's my 27. So I know that 5x is equal to 27. Divide both sides by 5, and I get 5.4. Now, I also know that diagonals bisect each other, so I know here that these two pieces are going to be congruent. Specifically, I know 2y minus 5 is equal to y plus 4. Now, we're going to get all of our variables on one side and our numbers on the other. So add 5 here. Those are going to cancel. Those are going to cancel, leaving me with y is equal to 9. That was simple enough. Now we've got to come up with z. Now remember how we talked about those congruent triangles? Well, actually, you know what? I'm going to do this an easier way. I know that these two are parallel. And when they're parallel, that means that here the diagonal QS is a transversal line, which means that angle RQS and angle TSQ are alternate interior angles. Therefore, they are congruent. So I know that 3z is equal to 33. Divide both sides by 3, and make it z equals 11. Okay, number 5. Find the coordinates of the intersections of the diagonal. Now, let's just think through this for a second. If I were to draw the diagonals on this, I know the diagonals bisect each other, and the important part of it bisecting is that's the exact midpoint of each diagonal. So all I'm going to do is pick off 2 of my adjacent or my opposite points from opposite angles. And remember, this is like a road map. It goes around the outside, A, B, C, D. So I'm going to choose the 2 points A and C and find the midpoint of the line between them. Now remember, the midpoint formula is average the x's, x1 plus x2 divided by 2, comma, average the y's, y1 plus y2 all divided by 2. Let me get rid of the d there so it's not in the way. So let's take our x coordinates of A and C. So that's 3 and 3. My y coordinates are 6 and negative 2. 6 and negative 2. Well, 3 plus 3 divided by 2, that's 6 divided by 2, which comes out to 3. Now, 6 minus 2 is 4, divided by 2 is 2. So there's the coordinates, just by finding the midpoint. Number 6, find the coordinates of the intersections of the diagonals. Exact same idea here. I'm just going to locate the midpoint. Divide by 2 plus plus. We're going to use A and C again. And so now our x coordinates, negative 4, negative 1. Y coordinates are 3 and negative 2. -4 plus -1 is -5. -5 divided by 2 is at -2.5. Now, 3 plus -2 is 1. 1 divided by 2 is 0.5. So, -2.5.5. Well, that's all we got for today. As always, reach out to me if you need any help. I'll be available on my Google Meet every morning at 8 a.m. The code is EVHS Mr. Love. And feel free to ask any questions. Let me know if you have any. Bye.